This is feedback and commentary on the in-class test M3 in mathematics vector algebra. In a space combat game, your fighter position is 4-2 and your velocity vector is -2, -2. There is also a beacon with a position of 0, -8. For this situation, we have asked you 8 questions, each of these requiring some vector calculations. The first recommended thing to do was to draw a diagram showing the position of the fighter, your velocity vector, and the beacon position. Question number 1 was about the initial distance between the ship and the beacon. This distance is the magnitude of the displacement vector which connects the both points. The formulas needed for this solution is the formula for the displacement vector and the formula for the magnitude of a vector. The calculation was relatively simple. Most people got it right. The average mark was 8.1. There were no particular problems apart from some minor calculational issues. The question number 2 was about the speed. Speed is the numerical value of the velocity vector, which is given as -2, -2, and requires simply the application of the formula for the magnitude of the vector. The calculation is now quite straightforward, but the average mark is rather disappointing, just slightly above 5 out of 10. This is mostly because many of you didn't notice the otherwise obvious relationship between velocity and speed, and instead you were trying to apply a physical formula for the speed, which is distance over time. The problem is that we didn't provide any distance. The fighter didn't fly towards the beacon, so if you took the distance from the fighter, from the ship to the beacon, it was wrong. And we also didn't provide any time. If you tried to use time of 5 seconds, which was mentioned in one of the exercises, it was irrelevant to this problem, and also such solutions were wrong. In the question number 3, we ask for the normalized direction vector. Normally, it is a normalized motion vector, such as the velocity vector. Therefore, you were supposed to calculate the normalized velocity vector. The velocity vector was given as -2, -2, and normalization simply means dividing this velocity vector by the speed value calculated in the previous question. However, a solution like this has been achieved by less than 20% of you, which was, when I marked this for the first time, rather a disappointing result. What I noticed then was that many of you, instead of calculating the normalized velocity vector, you have calculated the normalized displacement vector, therefore obtaining the normalized direction of the beacon. I have to admit that my question, which was calculate your normalized direction vector, didn't specify which direction I meant, and it could have been understood as the direction, normalized direction towards the beacon. Therefore, I have remarked this particular question and accepted the displacement, the normalized displacement calculation as an alternative correct answer, and this increased the average mark to quite a good value of 7.7 out of 10. Question number 4 is about the position of the fighter after 5 seconds of flight. It should be solved using the motion equation, and this question proved to be not very difficult for you. attracted quite a good average of 7 out of 10. The main problem that occurred with this exercise was with strictly calculations, particularly addition of negative numbers. The questions number 5 and 6 were about the relational position of the beacon against the fighter ship, whether it was in its front or behind or on the left or on the right, and they require calculation of a dot and cross product. The solution is shown here. The average mark for this question was 6.4, not bad, but there were several problems with your solutions. The major one, the most serious one, was with the selection of the two vectors for which you have calculated the dot product and the cross product. They must have been the displacement, a vector connecting the fighter and the beacon, that's one vector, and the second vector should have been any of the motion vectors, particularly a velocity vector, but it could have also been a normalized motion vector. If you have taken anything else, such as coordinates of the fighter or coordinates of the beacon, it would significantly, very significantly reduce your marks for this question. Apart from that, there were various problems with calculations, particularly multiplication, addition and subtraction involving negative numbers, in which there were a lot of mistakes, and some of them, I have to admit, quite devastating. In the question number 7, we ask about the azimuth angle using a radar screen like this one. If 0 is your current course, the motion trajectory or forward direction, at which angle should the beacon be shown? To find this angle, a formula for the cross product should be used. It could also be the dot product, but cross product will be a little bit more convenient. The calculation of the sine of the angle could have been significantly sped up by using the results of previous calculations, such as cross product in question 6, distance in question 1, and speed in question 2. The average mark was 3.2 out of 10, not very high, but this particular question was designed as a more advanced and more challenging question. In question 8, we ask for the coordinates of a point on your route where you are closest to the beacon. Expanding our diagram by showing the further motion trajectory of the fighter, we can show the point we are looking for as px. This kind of an exercise has been discussed at one of the recent lectures, and it was demonstrated that a use of a single formula is required to find the solution, and to be more exact, to find the d prime, the projection vector of the d displacement in the direction of the motion. The calculations shown here may be not the most straightforward, possibly, but still the average mark of just 2.4 out of 10 is a little bit disappointing. Simply, most of you didn't even attempt this particular exercise. The overall average of the entire test was 50 out of 100. Whilst it is not bad, I could have hoped for more. I am reasonably pleased with your knowledge of vector algebra. You knew, in most cases, you knew all the operations, you knew how to calculate cross product, dot product, which vectors to choose, and so on, so on, so on. So your general knowledge of vector algebra is most often sufficient, and hopefully where you have to solve a programming task involving vectors, you should be able to do it. Where I am much more concerned is about your plain mathematics skills. So what I mean is that if it comes to vectors, you more often than not, you know what to do, which vectors to select, and so on, so on. But at the same time, you quite often, too often, you make silly mistakes in simple calculations like multiplying or adding negative numbers, like squaring numbers, like finding square roots. These are simple, too simple errors that occur too often, and this is my main concern after seeing all your results. Fortunately, my marking scheme was mostly based on your skills in vector algebra rather than this plain mathematical skills, but still, just have a look at my black list of mathematical silly equations. Thank you.